If you're watching this video, then you must have successfully found it, which is good. So hopefully the directions here on the front page and the following pages have been helpful for you. Now that you've made it, let's get started. Okay, today we're going to look at equivalent equations. Okay, so remembering that there's a difference between expressions and equations. Okay, and we are going to start with expressions, and expressions don't have equal signs, but we are going to work our way towards equations, and equations always have equal signs. Okay, so again, the focus is on equivalent equations. Okay, now if you look at the first set of questions here, it says show that the following expressions are equivalent. Okay, so we want them to look the same. Okay, and if I look here, I'm noticing that I have two terms that have x's, which means I can combine them. And 4x plus 3x is 7x, and copy down what's left. Okay, and I get 7x plus 3, which is equivalent to this 7x plus 3. Okay, so we would say that by combining like terms, we've made equivalent equations, or expressions, excuse me. Okay, now for number 2, there's a couple different ways we can go about this, okay, but again, I'm noticing like terms. Okay, both of these are constants, so they can be combined. Okay, so we would have 4x, and then 1 plus 5 is a positive 6. Okay, and from here, okay, I might recognize that there's a GCF of 2 that can be pulled out. Okay, and when I divide these each by 2, okay, 4x divided by 2 is 2x, and 6 divided by 2 is 3. Okay, so by combining like terms and then factoring, we've created expressions that are equivalent. Okay. Similarly here, okay, I'm noticing that this can be distributed. Okay, so I set up my box, 2 on the side, x minus 5 up top. 2 times x is 2x, and 2 times negative 5 is negative 10. So I'm getting 2x minus 10, which is equivalent. So for this one, we distributed. Okay, so there's different strategies, different methods we can use to make equivalent equations. Okay, you'll notice, for the first one we're combining by adding and subtracting, the next one we were factoring by dividing the 2 out, and then this one we distributed, which is multiplying. Okay, equivalent equations are equations that have the same solution. Okay, and by solution, I mean answer. Okay, they have the same answer. Okay, and we can use our operations, okay, adding, subtracting, multiplying, or dividing to create or to produce these equivalent equations. Okay, so go ahead and finish filling that out, and then when you're all set, flip the page. Okay, on this page, okay, this is key. Equations must always be balanced. Okay, and that's why I have these balance beams here. Okay, we're going to do a little investigation. Okay, it says if we subtract 2 from both sides, will the equation still be balanced? Okay, so as of right now, x minus 1 is equal to 7, which means the two sides are balanced. Okay, now if I took that original and I solved for x, okay, add 1 to both sides, I would get x equals 8. Okay, now if I alter this by subtracting 2 from each side, so here's your original, minus 2, original, minus 2. The question is it still balanced? Okay, so let's find out. Negative 1 minus 2 is negative 3, and 7 minus 2 is 5. Add 3 to both sides, x equals 8. Do they have the same solution? Yes, they do. So these are equivalent. Okay, they're still balanced. Get to the same answer. Okay, similar process here. If we look at the original, x minus 3 equals 5. Okay, we're hoping to keep it balanced. Okay, so this has a solution of 8. Okay, that's the answer. And the question here is asking us to add 3 to both sides and determine if it's still balanced. Okay, so here's your original, adding 3. Here's the original, adding 3. Okay, negative 3 plus 3 is a 0 pair. So we get x, okay, those cancel, equals 8. Same solution? Yep, so it's still balanced. Okay, this one they're asking us to multiply both sides by 2. Okay, so we start here, nothing really to solve, but if I were to multiply, okay, 8 times 2 is 16, and then solve, okay, which seems a little silly, we get the same solution? Yes. Okay, still balanced, still gets us back to the correct answer. Okay, and lastly, okay, our fourth operation, division. Okay, here's your original, 2x equals 16 is a balanced equation. Divide by 2 on both sides, we're getting x equals 8. Okay, and then if we divided both sides by 4, okay, so the 2x divided by 4 equaling the 16 divided by 4. Okay, break this down a little. 2 over 4, okay, if I divide top and bottom by 2, 2 divided by 2 is 1, and 4 divided by 2 is 2. X equals 16 divided by 4 is 4. Okay, now for this one, okay, the opposite of that, okay, we want to multiply both sides by 2. Those cancel, and we get x equals 8. Same solution, still equivalent. Okay, go ahead and finish filling out this page, jot down any questions you might have you want me to answer for you tomorrow, and then flip the page. Okay, so this is the heart of what we're getting at, identifying equivalent equations. Okay, so state whether each pair of equations are equivalent equations, give a reason for your answer. Okay, so here we go. Okay, I'm going to look at, okay, there's 2 different equations here. Okay, the first one and the second. Okay, and I want to start solving them, okay, or getting them into a form where I can make them equivalent. Okay, so for this, I'm always going to draw my river on the equal sign. Okay, but before I start solving things, I'm noticing that I have an x here and a 6x here. Okay, and because they're like terms, I can combine them. So 1x plus 6x is 7x plus that 3 equals 13. Okay, and if you take a moment to pause and reassess, you notice that you already have equivalent equations. Okay, so they're the same equation, okay, literally identical, which means they must have the same solution, which means they have to be equivalent. Right, because the definition of equivalent equations is they have to have the same solution, okay? And we're going to see that a little bit more for example B. Okay, so for this one we can't just look at it and know. This one we actually have to solve. So I'm going to draw a river on the equal sign. Okay, and I want to move everything except for the algebraic term. Okay, so the 5x I want to leave alone for now, but the opposite of subtracting 4 is to add 4 to both sides. Okay, and I get 5x equals 10. Okay, now the operation here, okay, this is 5 times x, and the opposite of multiplying by 5 is to divide by 5. Okay, and I get x equals 10 divided by 5, which is 2. Okay, so the solution to that equation is x equals 2. Okay, now I'm going to look at 5x equals 20. Okay, and I'm going to draw my river. Okay, and then again, 5 times x, well the opposite of multiplying by 5 is to divide by 5. Okay, and 20 divided by 5 is 4. Okay, these have two different solutions. Okay, the solution of the first one is 2, the solution of the second one is 4. So we should say, okay, different solutions. Therefore, not equivalent. Okay. And last example here. Again, this one's a little trickier. We actually have to solve. Okay, now these are the tricky ones where the coefficient, okay, the number in front of the letter, is actually a fraction. Okay, so I'm going to rewrite this, give myself a little bit more space. Okay, remember, okay, this, okay, is 2/3 times x. Okay, and the opposite of multiplying by 2/3 is to divide by 2/3. Okay, but remember, when we divide fractions, we have to flip and multiply. Remember, keep, change, flip. So I'm going to flip this over and multiply. Okay, and whenever we do to one side, we have to do to the other. Okay, now this is all going to go away. Okay, leaving me with just an x. Over here, I might want to do a little bit of work off to the side. Okay, 4 over 1 times 3 over 2. Okay, 4 times 3 is 12, and 1 times 2 is 2, and 12 over 2, or 12 divided by 2, is 6. Okay, so I'm getting x equals 6, and comparing that to my other solution, and they are indeed the same. Okay, so we would say same solution. Therefore, equivalent. Okay. Jot down any questions you have for me, finish filling this in, and then on the next page, you have 4 questions that I want you to try on your own. Okay, so get these done. I'll be checking these tomorrow in class and giving you an answer key. Have fun!